Mining for Bitcoin. Is there gold in them there hills? Maybe and maybe not. In this nugget, we're going to focus on the critical role that miners have in maintaining the blockchain by putting a lot of CPU power into validating each and every new block in the blockchain. Let's begin. Our objective for you and I in this nugget is simple. We're going to take a look at what is Bitcoin mining, why would somebody choose to do it, and how has mining evolved over time, and what are some new techniques that we can use, including mining pools, to help improve our return on investment. Let's start off with a transaction. In Bitcoin, I've got a question for you. If we have a Bitcoin transaction between Bob, for example, and Lois, what is it that allows Bob to go ahead and give Bitcoin or assign Bitcoin to somebody else? And the answer is he has access to the private keys for which that Bitcoin is currently associated with. So if Bob has, for example, 300 Bitcoin and he wants to transfer or assign 2 of those Bitcoin over to Lois, he would use a software client, either his traditional wallet client on his PC or maybe an e-wallet like on blockchain.info. He would get Lois's address, say he wants to send that money, he hits the button, and is it verified immediately? The answer is no. What happens is that transaction gets broadcast. Now, it gets broadcast to the Bitcoin network. You might think, well, that's not very anonymous. Well, the Bitcoin network has to verify the transaction, so all they know are the keys involved and the addresses involved. They don't know it's Bob's or where he lives or what his address is. So the Bitcoin network gets a copy of this transaction. And then what they're going to do, they're going to collect all the transactions that are happening, and they're going to form what's called a block. Now, here's what I think will be helpful. Whenever you see the word block in the concept of Bitcoin, let's think of a group, as in a group of transactions. So all these transactions get collected and logically put into a block by the miners, which is computers, our computers that are running on this Bitcoin network that people are volunteering to participate in. And then what they're going to do is they're going to try to solve it. Solve the block. Now, what exactly does that mean? I like to think of it like solving a riddle. And to really appreciate this solving of the riddle, I'd like to teach you a little bit about hashing, just in general. Now, I come from a computer background, computer networks and some security, and what I'd like to do is talk with you about 2 PCs. There's PCA, and maybe that's you. You're sitting at this computer, and you're tied to a network. Maybe there's a layer 2 switch there, and a router, and another router, and another router, and a whole bunch of networks that we don't want to describe, and another router, and a switch, and then we have me right here. So that's you, and that's me, and that's a whole bunch of network stuff in between us. Now, if you wanted to send data over to me, and we wanted to make sure that we had data integrity, meaning, let's say you want to send a message, hi, how are you? And let's say that's going to be one packet of data that's going to be sent over. If we wanted to make sure that no one in the middle manipulated that message or corrupted it in any way, what we could do is have some kind of a secret. Let's say we have a key, a little secret that only you and I know. Let's call it ABC bang 2 3. And you know that secret, and I know that secret. We negotiated that with another protocol that's beyond the scope of this. But let's say we both know what that secret is. And so what we could do is we could create something called a hash. Before you send this packet, you could run a mathematical formula on this packet of data, and you could include the secret key as part of that mathematical formula and create this teeny little, they call it a digest. It's just very small. For example, if this was like 12 or 14 characters or however many it is, maybe this is like 1 or 2 characters. It's very, very teeny, but it's a mathematical computation on this whole string of text plus the secret. So then we attach it, this little digest, very, very tiny, and then we ship it across. So the message and the hash goes all the way across the network. So it gets forwarded, 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 all the way over. Now when it gets to me, I take the message, and before I believe it being valid, what I'll do is I will run that same hashing algorithm on the packet, on the message, hi, how are you? I will include inside of that math my secret key that you also have, and then I will calculate my own hash. And if the hash I calculate matches the hash that you sent, guess what? I know that nobody in between you and I manipulated that data. So a hash is one method of verifying data integrity on a network, and they're not reversible. For example, somebody can look at this hash and say, oh, the message is, hi, how are you? It's a one-way hashing function, and there's lots of different flavors of it. So Keith, what has this got to do with Bitcoin? Well, each of the devices, each of the miners who have this block of transactions are going to have to create a hash on the actual content. Now, that content of the block is going to have information about the previous block because it had a hash as well. It's going to have a whole bunch of different transactions in it. And what they have to do is generate a hash, but it can't just be any hash. The hash is going to have a whole bunch of leading zeros. To really appreciate the work that a miner computer is going to be doing, let's go ahead and do it manually, just for fun. And let's say we're taking the payload, which is some data related to the things that are currently happening in the Bitcoin network. It's going to involve information related to the previous block, the current transactions in the block we're working with, and what our goal is to create a hash that has a whole bunch of leading zeros, let's say 13. And that requirement will change based on how fast blocks are being solved. But at the moment, this is actually a live hash from a block that was recently solved. Let's go ahead and say that the hash has to have 13 leading zeros. And it's not reversible, meaning the only way we're going to find a hash with 13 leading zeros based on the current block is by brute force. So it goes something like this. This nonce value is just a number that we're going to use as part of the hash. And we don't know what nonce or what random number we're going to need to use. So let's start with 0. And we'll click on calculate the hash. And here's the hash. Now, I've got no leading zeros there. That's not going to work out. That's 1. One try. And let's try a value of 1. And click on calculate hash. It changed significantly because our data changed, but it's not the value with a whole bunch of leading zeros. So we'll try a 2 and we'll click on calculate hash. No leading zeros. And then we'll try a 3 and calculate hash and no leading zeros. So this is how it goes. If let's say the requirement is that on a current block that we have to have 13 or 14 or 15 leading zeros as the hash, we are going to have to try, I think the technical term is a boatload of nonces. Now, a nonce is just a name for a number used temporarily. So just out of brute force, we're going to try 3, 4, 5, 6, 7, 8, 9, and hopefully we have a computer that can crank out millions of hashes per second as we desperately try to figure out a hash for the current block that would meet the requirements of how many leading zeros they're looking for. And the reason they have the leading zeros is to make it kind of difficult. So with tens of thousands of computers all cranking away and cranking away and cranking away, as soon as one of those computers tries a number and they actually get a hash that has the required leading number of zeros or a minimum number for that hash, they're then going to go ahead and shout out, "I got it!" So you've got this one Bitcoin miner in Des Moines, Iowa, or in Germany, or wherever that, Japan, or wherever that miner happens to be. He yells out to the Bitcoin network saying, "I got it. Here it is. Here's the hash, and here's the formula for it." And everybody else on the Bitcoin network says, it's like bingo, right? If you ever watched a bingo game, when somebody goes, "Bingo, I got it." And everybody else is like, I was so close. That's emotionally, that's what all the other miner computers might be thinking. But here's what they do. They say, okay, you came up with the correct information to create that hash. They will verify it. They'll verify, yep, the number 423790089, blah, 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 blah. As the nonce with all the other data, that is the correct data that actually will generate this hash. And what they will also do, all the other miners, they'll also verify that all the transactions in that block have not been double spent, meaning no transactions had a Bitcoin that was trying to go from one address to somebody else, and that same Bitcoin was going to someone else. So they'll verify as a group that there's been no double spending, and then they'll all agree that, okay, that block has been solved, on to the next block. And they take the next block, and that happens approximately every 10 minutes. Now, why would somebody do this? Why would they participate? Why would you throw your computer in the ring? And the answer is, at this day and age, this is February 2013, at the moment, it's 25 Bitcoin is the reward for the computer that can solve the block. So when they talk about somebody calculating a block, there's one successful computer every 10 minutes, and that one successful computer gets an award of 25 BTC. And it's not like a ceremony. They don't have an award ceremony. You won this and here, congratulations. When that miner verifies the block, he figured it out, he is automatically assigned keys that, guess what, have the Bitcoin associated with it. And there's a short waiting period just to verify that it really did happen and everything else. But that miner just got 25 BTC associated with keys that he now controls. So it's really like two things in one. Number one, we have a whole bunch of computers madly racing to verify the transactions and to confirm the details of the blocks in the blockchain. And secondly, we have a method to release currency slowly into the Bitcoin network. So if we take a look at the details of one of the blocks, this is on blockchain.info. So this is the main page. If we click on one of the current blocks, it's going to show us the details for it. Here we have the hash for that block. This is the hash for the previous block. It was reported as 468 transactions in that block. Here's the lucky son of a gun who actually reported it. And here's the nonce he came up with. So if we were doing that manually, where we started with 0, 1, 2, that would have taken a long time to get to that many digits. I mean, if I look at that, I think that's like 4.2 trillion. That would be a lot of tries. And hopefully we had a very fast computer that could do it a lot faster than we were trying to do it manually. If we want to get kind of like a bird's eye view of who worked on this block, we can click right here under network propagation. I think you'll like this. It's going to go ahead and show us a distribution of that block through the network of everybody who is involved in working on it. And if we click on these, we can even drill down further and get more details. So if we go back to that same one and we open up that block, if we scroll down a little bit, it's going to show us the transactions in that. So there's a total of 468, but the very last transaction right here is for $536. That's US. Now that's based on the current exchange rate. If we change this back and say, you know what? So if we go back to this and say, you know what, I want to see this in BTC, from Bitcoin, it's going to show us that it was 25 point something BTC. Now the 25 Bitcoin itself came from the Bitcoin network, and the 0.383 and so forth change was additional transaction fees that people had included when they wanted to do their transactions, whether it was 0.001 or some fraction of a Bitcoin. So this money right here represents the 25 Bitcoin that was awarded to that IP address, which may be an individual or it may represent a group of miners who are all going to share the profits of that for his participation and their participation in doing the mining in the Bitcoin network. On Blockchain Info, they've got a lot of really great information that's right there at our fingertips. If we go to Blockchain Info, go to charts, it has total Bitcoins in circulation. So this chart right here represents the fact that right there, previously they were handing out 50 new Bitcoin for every block that was solved. And what happens is every 210,000 blocks, it goes to half that amount. So right here, they're now handing out 25 BTC when there's a block that's been solved by one of the miners. And then that'll go down and down further. So one of the ideas is, well, Keith, why will people want to continue doing mining for Bitcoin if they're reducing the rewards as more Bitcoin is released? Well, the answer is once we get to about 21 million Bitcoin, there will be no more Bitcoin released at all. But what we will have is very, very small transaction fees that will go to the miners who solve the actual block. And so the motivation is still going to be there in the right place. And that transaction fee is going to be so small compared to what we're normally dealing with banks that we're going to be happy to contribute it for the service of Bitcoin. Another interesting chart while we're here at blockchain is the market capitalization. This is basically taking all the Bitcoin that's currently been released at the current exchange rate in US dollars, what would it be worth? And the answer is, now today it's currently trading like $22 or so. And this is saying that if you took all the value of all the Bitcoin at the current exchange rate, it's almost $250 million. Now I can tell you this, at Christmas time, at the end of last year, end of 2012, it was about 150. So as more people buy into Bitcoin and can start to use it and purchase it and trade their fiat currency for Bitcoin, that's what drives the price up. It's basically supply and demand. Another interesting chart is the number of My Wallet users. These are the wallet customers at blockchain.info, and it's steadily going up. So that would also account for the fact that more people are using Bitcoin, purchasing Bitcoin with their fiat currency, and either holding on to it or transacting with that Bitcoin. We could also compare that against this is the number of transactions per day with Bitcoin. And so the cool thing I love about Bitcoin is that all the data is there. The actual blockchain itself is not encrypted. There's no secrets about the actual data that's the blockchain. So we can look at volume, transactions, and everything else. So while it's true that every transaction is protected by cryptography, the results, the raw data of what's happening is out there for public display, and it's on thousands of computers that are maintaining the blockchain. Here's another really fun graph up at blockchain.info, and this is the hash rate. Now, each computer that's a miner is desperately trying to figure out the correct nonce to plug in to actually create the hash that meets the requirements. And then they win the pot of gold, the 25 plus change Bitcoin for the current blocks that are being solved. So if we take all those computers and all the work that they're doing, we can have a collective hash rate of, and so here we have the hash rate. This is hash rate in giga hashes per second. If we take a look at a point right here, that looks like 28,000. So that's gigahashes. So there's like 28 terahashes per second. We're talking about some serious distributed computing power. For what purpose? For maintaining the blockchain, which is absolutely awesome. So let's imagine that you and I want to look into doing mining. We have a computer or two laying around. We think, hey, we could put it to work and maybe we could get lucky or join a pool and earn some Bitcoin for assisting in solving of the next block in the blockchain. Well, let's take a look at the evolution of where we've come in this very few short years. Now, 2009 was the beginning of Bitcoin. And now it's 2013 as this is being recorded, and where it goes in the future, only time will tell. But when we started doing mining, it was based on CPU. Now, what is a CPU? That's a central processing unit. That's the computer chip on your computer. So you have a motherboard, you have a computer chip on your motherboard. Now, if we're just using the CPU, we could probably crank out somewhere between 3 and 10 million hashes per second. And that'd be pretty good. You know, we were doing it manually. I think our rate was like, well, it was like 5 seconds per hash try if we were plugging in 0 and then 1 and 2 and 3 and 4. But a CPU could crank out 3 to 10 million hashes per second, all trying to figure out the perfect hash that meets the difficultness requirement based on the Bitcoin network at the current moment. And I say the difficulty at the moment because every 2 weeks or so, I shouldn't say or so, every so many blocks, which equates to every 2 weeks, if there's too many, if the blocks are being solved too quickly, like less than 10 minutes, the difficultness, or the difficulty level, I should say, of the hash that has to be solved is going to increase. If we went the other direction, and let's say the blockchain was, a new block was being added every 12 minutes or 13 minutes and was too slow, the actual level of difficulty would be reduced. So maybe they start asking for 12 zeros or some other combination that will be easier to solve or more likely to be solved. Because here's the reality. If we had a computer like this, a CPU, and we were trying to solve and get a hash like this on some block of data, it probably wouldn't happen in a year. A computer at 3 to 10 mega hashes per second sitting for a full year wouldn't be likely to get it. Now we're talking about creating these and solving a block in under 10 minutes. And that's because we have thousands of computers doing it with all that collective power. That's how we get the terahashes per second collectively as a group with lots of different computers all trying at the same time. So although the CPU sounds pretty good, 3 to 10 mega hashes per second, it really isn't. There's actually a better way to do it. We could use a graphical processing unit. I'm talking about our video cards. And because they have the processors built to handle video, they happen to do hashing a lot better than our CPU. So if we use a GPU, we might be able to get up to, for example, 32 mega hashes per second. And depending on your GPU, not everyone is built the same, we might actually get up to 600 or 700 mega hashes per second. And there's tons and tons of documents out there. If you search for Bitcoin mining and GPU, what video card, there's just documentation after documentation saying this video card does this and this video card does that, and here's how to tweak it, and here's the operating system you'd want to run to optimize that process. But you can see how somebody with a GPU, a graphical processing unit, in their video card doing 700 mega hashes per second is going to have a bunch more success than somebody with their CPU at 3 to 10 mega hashes per second. It's just orders of magnitude faster. So, you know, the human mind often has the idea of bigger, better, faster, stronger. How do we build a device that can even do more than 600 or 700 mega hashes per second? And so they have this FPGA. And what that's all about, that's a field programmable gate array. Basically, it's a computer processor that you can program. So you build it generically and then you can program it like with firmware. And if you have this FPGA, the speeds increase above even what a GPU can do. So for example, a quad FPGA might be able to get 1 gigahash per second all by itself. So this is the evolution that we've been seeing, and what's happening is the miners are going crazy and they're putting all kinds of really amazing rigs together for Bitcoin mining. So let me tell you about the next step that is happening right now. It's been promised for several months, but the actual vendors are starting to release it, and that's something called ASICs. Application-specific integrated circuits. Back in the old days of networking, we had some devices that were forwarding traffic between, like, for example, PCA and PCB and C and D, and they would do it, fairly efficiently. But once we moved the logic into hardware, and not doing it in software, but doing it in hardware, it was a lot faster. And that's what application-specific integrated circuits are all about. If we have ASICs for the purpose of Bitcoin mining, the actual rates that they're claiming that might be possible with that are 3 gigahashes per second all the way through 1,000 gigahashes per second. That'd be 1 terahash per second. We'll see if that comes out. My one word of caution for you is this. That sounds like a great gig, and then no pun intended, but that sounds like a really great thing. I would make darn sure, though, before you lay out $30,000 or whatever the cost is for this thing, I would make sure it's working. I would make sure it's real, that it's not just some vaporware in somebody's mind, but it's actually a real product. The other reality is that once we have people purchasing these, all the Bitcoin miners, or a lot of them, are going to do it. So as the tide rises, all boats will rise. And if the blocks start getting solved too quickly, the system will automatically adjust and will increase the level of difficulty for the hash on the upcoming blocks. So every 2 weeks it adjusts a little bit. So blocks will continue to happen every 10 minutes, and the rewards are not going to really increase above and beyond what they are now, which is basically 25 Bitcoin and a little bit of change for solving each and every new block that is calculated and then added to the blockchain. So let's have some fun. I went up to Google and I did a search for Bitcoin mining, and then I selected images just to have some fun. Let's go ahead and let's just grab one. How about this one? Let's do this one right here. That's good. So here's what we have. We've got somebody with a whole bunch of GPUs, they're graphics cards, and they have little ribbon cables that put them on the motherboard, and they're hanging, so for ventilation mostly. Now they might not physically fit next to each other inside the chassis. You have 1, 2, 3, 4, 5 of those video cards, and he's probably running some dedicated software just for the purpose of mining. He's probably watching he or she is probably watching the temperature in the room, making sure it doesn't get too hot because he doesn't want to damage any of the circuitry. And it looks like he has a whole nother rig over here as well doing the same exact thing, which is a lot of fun. My hat's off to everybody. And down here it looks like we have a gingerbread Bitcoin mining rig. But you can also see that a lot of them have fans as well. Or here we go. This guy has a duct directly connected, sucking the air out of the house, which is fantastic. One of the important things, I think, in deciding if you're going to do Bitcoin mining and invest in hardware is consider, okay, what is this going to cost me in electricity? What are my returns? It's very likely that if we mine all by ourselves, it's very likely that our mining rig, our computer that's doing the mining, it's very likely that we are not going to be the lucky person who solves the actual next block in that chain, because there's so many devices doing it. So one way of improving our odds in getting paid or reimbursed for doing mining is to join a winning team or to join a mining pool. So if we join our computing power with those of maybe 4,000 or 5,000 other devices in the same pool, and if any one of those devices actually hits the jackpot, we can all make a little money off of it. When I talk about a little money, I do mean a very little money on that prospect. And there's different ways of being paid, and I wanted to introduce you to some of those concepts. So let's take a look together at a couple of different ways we could join a mining pool. There's lots of mining pools out there. One of the ones that I've heard high things about is btcguild.com. And with BTC Guild, there's a couple of different ways that you could elect to be paid. One is pay per share. So you bring your mining rigs, you associate yourself with this mining pool, they give you blocks. See, they don't want the same actual strings, the same nonsense to be tried by two different computers. That's a waste. So they actually allocate. It's all done with a program. They allocate the different ranges they want devices to try. And then every device, every computer that's cranking out is going to be paid in proportion to the work that they do. So pay per share is 1 divided by the current difficulty times 23.75. And whether or not the entire group actually solves a block and is rewarded the Bitcoin by the network, they will automatically pay you. And that's why they shave off a little bit. Instead of doing a factor of 25, they do 23.75. That's to cover their risk. The other option, pay per last N shares, PPLNS, is going to reward you for your participation if the group solves a block. So hopefully your computer, your mining rig was going at it and participating at or fairly near the time that that block was solved, and then it's payday. Now, the negative side of that is if the block isn't solved and you're doing all the work, there's going to be no reward, no income based on your participation if there's no block solved. Another bit mining pool that I've heard great things about is bitminter.com. And if we take a look across the top, they should tell us about, I'd like to have one that shows how many, there we go. It has 1.52 tera hashes per second across their network. That's a lot of CPU power just trying to solve the next block and the next block and the next block. And to get a feel for what the interface looks like, if you scroll down just a little bit, they've got a test page. Now this test page, there's a warning says you're not getting paid for this. You're just testing it out just to see what it looks like. So I'm going to click on this test start, and it downloaded this little JNLP file, and my browser saying, hey, you sure you want to keep this? I'm going to say, yes, I'm doing a demo. I want to keep it. I'm going to go ahead and launch it. And it's not. Oh, okay. So normally on a computer, you'd never want to run an application or anything else if it's not signed by a trusted entity. Now, this did literally come from Bitminter. I'm not at HTTPS, but I do have reason to believe I'm at the right site. I'm going to go ahead and run it. But just as a word of caution, in general, you probably don't want to run suspect or applications if you just aren't sure what they are. So this little test applet I'm fairly comfortable with. I'd be more comfortable if it had been signed, but that's okay. So this is what the interface looks like. This is just a little test, and it says, okay, found one OpenCL compatible GPU. So it likes my video card. Awesome. So I've got some type of AMD card in there, and it seems to like it. So if I click on start the engine, it's actually going to tell me how many mega hashes per second this GPU is going to be able to go ahead and do. So as that cranks up, wow, that's not bad. So this is doing 500 and whatever the change is, 542 mega hashes per second. So this is an example of what my video card can do. Now, I need to tell you something really funny that's happening in the background. My video card has a built-in fan, and I can hear that fan as we speak winding up, going faster. In fact, it's a high-speed hum that I rarely hear, and that's because I don't do a lot of heavy-duty video work. But because right now it's taxing that GPU and it's doing 545 million hashes per second, it's actually getting very hot. And I'm going to go ahead, I'm going to click on stop. And sure enough, the fan immediately started winding down a little bit. So back down to its normal state. So I can see why somebody who has a whole rack of GPUs, video cards, and using some specialized software is going to have fans to keep them all very, very cool so that they don't burn up. But that's an example of how we could actually use and become part of a Bitcoin mining pool. Now, the actual full client looks very similar to this, except I would have an account at Bitminter, and I would log in with my credentials, and that way any of the work I'd been assigned for hash calculations, I could get credit for as part of the pool. One other tip I wanted to share with you about mining is that if you're going to get into it, which a lot of people do, you could do it for lots of different reasons. One is, hey, it's Bitcoin. It's this brand new idea. I want to be part of it. Fantastic. Go ahead and do mining. Other individuals are saying, well, hey, it's like the gold rush. I can become part of a mining pool and make money by my computer sitting idle. Well, a long time ago, a few years ago, that could have been true. Today, with the higher GPUs and the mining rigs, and now ASICs coming out, if you want to participate in a mining pool and actually have a pretty good return on that, you're going to have some fairly hefty equipment cranking out lots and lots and lots of hashes per second to get that ROI back in. I also want to point out that besides the worksheets that are available to calculate power and everything else, I would also strongly recommend that before you purchase any ASICs or any dedicated hardware for mining, just verify that what you're going to purchase is real, that it exists, and it also works. So there's a lot of solutions where we have dedicated operating systems that live on flash drives that control GPUs or the FPGAs. And there's lots and lots of documentation on tweaking and tuning and optimizing. And I would just recommend that before you go for a solution and purchase anything, make sure that the solution you're getting is going to meet your needs and that you've done your homework up front on realistically what the income will be from Bitcoin mining. So now that we've taken a look at some concepts regarding how we could do pooling of resources for Bitcoin mining, I wanted to share with you this URL. This is blockchain.info in the pools page. And if we scroll down a little bit, this is over the last 24 to 48 hours. Most of the work that's been done has been done by the actual groups. We have BTC Guild, that pool 20%, and 50 BTC, and DeepBit, and Slush, and Eclipse MC, and BitMinter, and Ozcoin, all with their respective parts of how much they solved. If we scroll down further, it'll give us the details. So BTC Guild, and there's each of the blocks that they solved. If we click on the details of that block, so here's the hash involved. If we scroll down, there's 769 transactions in that block. So here's the magic number, the nonce, that was the secret sauce to creating the perfect hash that was valid for this block. Here's the block reward of 25 BTC and a little extra coin that was chipped in by the people doing the transaction that acts as an additional motivator for the Bitcoin network to do mining. Another really fun page I'd love you to check out is blockchain.info/nodes-globe. And you can actually scroll this one around. So it shows every part of the country with little indicators regarding the miners who are doing work. And if you scroll across, there's North America and South America and Europe and everything else. It looks like Africa doesn't have quite as much activity as do other parts of the world based on the computing power that they've got going for Bitcoin. So there we have Australia and New Zealand, and they've got some activity there. And it's just kind of fun to actually take a look at who is doing the actual mining work around the planet. In this nugget, we've taken a look at how critical the role of mining is in the Bitcoin network and why people would do it. And the primary reason is for financial gain. We've also taken a look at the evolution of mining and the processing power that's gone up, up, up to create more and more and more hashes per second in a race to calculate and solve the next block in the blockchain. We also identified that to actually get rewards and revenue coming in for mining, we have to solve that next block. And to do that as a group of computers is much more likely than if we're doing it on our own. I've had a great time. I hope this information has been informative for you, and I'd like to thank you for viewing.